Hello everyone, and welcome to our webinar on evolution of a lubricant, a solution against fretting corrosion. And thank you for joining. Next. Let me first introduce you our company. Microglide is part of the Coventya group. Coventya was founded in 1927. We are headquartered in Paris, in France. We are a globally specialty chemicals company focusing on metal finishing and surface treatment. We are among the top 3 global suppliers in this area. We are active in almost all countries in the world. We have more than 10 manufacturing sites and almost 10 R&D centers. Our quality certifications are 9001 IATF 16949 and ISO 17025. And Microglide is part of the Coventya family since 2018 with specialty lubricants. We serve almost all industries that you can think of, every manufacturing industry that has something to do with surfaces and need our technologies to improve corrosion protection or appearance or wear resistance or other functionalities. And with the addition of specialty lubricants, we enhance our portfolio. Our product range comprises pre-treatments, protective coatings for anti-corrosion purposes, decorative coatings for appearances, functional coatings for wear resistance such as electroless nickel and hard chrome, precious metals, aluminum treatment, anodizing, and then finally water care to treat hazardous waste. Let me introduce to you Franz Neuner, who's giving the presentation on fretting corrosion. He's got a wealth of experience, more than 35 years in tribology and related sciences. He's an expert in anti-friction coatings, greases, grease pastes, specialty dispersions, adhesive and sealants, new process automation, nanoparticles. And he's been active in almost all industry segments such as automotive, general industry, forging and die casting, batteries and fuel cells, chemical industry, and many more. Franz, if you want to start.
Yeah, good morning, ladies and gentlemen. Many thanks for your participation in our webinar today. Unfortunately, within the given time, we can only scratch the surface of the subjects. But please let us know if you need more details, or you can send us emails or whatever communication you prefer. Today we will start with a short explanation of fretting corrosion. What is it and what you can do to avoid it? Furthermore, you will see some details of our development work for our new generation of lubricants. Starting with the voice of customer, we will finally see some details about our current new portfolio of micro-white greases and pastes. Okay, let's start with some tribology. Tribology is the science of friction, lubrication, and the boundary effects on the surface when you move parts. Microglide always has been and is specialty lubricants. Our long-standing experience and expertise is the warrant for state-of-the-art products. It's important to know that we do not cover all areas of lubrication. So we are not in, for example, engine oils. We focus on specific product segments. And in these segments, we are really strong and mostly we are market leaders. For example, when it comes to lubrication of fasteners, threaded connections. Greases and grease pastes with micro-white solid lubricants are one of these focus segments. What are micro-white solid lubricants? They are powdery additives for greases, oils, or coatings. Usually they work as EP, extreme pressure, or anti-wear, AW additive. They are found inorganic, like hydroxides or phosphates, or organic types, like PTFE or polyethylene. Their average particle size is between 0.5 and 50 microns, depending on the application. Inorganic microwide solid lubricants are effectively used in greases, pastes, and grease pastes. You might wonder what is the difference between grease paste and grease paste. You can see the small table here, and it's just about the solids content. So a grease usually contains less than 10% of solids, grease paste less than 35%, and lubrication paste is up to 50%. This is not only just for fun, it also reflects the final application the product is used. So the greases are for roller bearing, as you know, the typical grease, and lubrication pastes are mainly for assembly and running in applications. Yeah, for many years, our GP series lubricants have been the benchmark products against fretting corrosion, used in many applications worldwide. But as we are continuously striving for the better, we decided to take a step into the future and develop the next generation of microwide solid lubricants. Fretting corrosion, what is it? It is not really common in our daily language. Fretting corrosion or vibrational wear is a very aggressive wear phenomenon. So it combines basically all wear mechanisms like abrasion, adhesion, fatigue, and therefore is very effective. It's able to destroy mechanical parts within short time, and therefore may be the related risk is pretty high. Here on the right side, you see some parts which are suffering from fretting corrosion. The joints here, the wedge connection, the bushing here, and here some brinelling on the thrust bearing. These are quite typical appearances. Fretting corrosion in most cases is coming with rust, red rust, and other iron oxides. And therefore in practical life, it's often confused with water-induced corrosion. But this is awfully wrong. Due to misinterpretation, fretting corrosion is not so well known in daily practice. However, it is estimated that about, let's say, 1/3 of all damages are related to fretting corrosions. What's needed to create fretting corrosion? First of all, you need friction partners. Like here, the ball and the plate on the right side. You need static or dynamic load, so here with the red arrow, force, and you need friction between the parts. It does not matter which kind of friction you have. You can have drilling friction, you can have oscillation, sliding, rolling. This does not basically matter. All movements may induce fretting corrosion. What's you definitely need is oscillation or vibration, and ideally in the range order of magnitude 5 to 500 microns. Critical, as we talk about oscillations, you need a frequency, and typically fretting corrosion appears at frequencies below 100 Hertz. Okay, so you might wonder, are there many parts which are impacted of fretting corrosion? The bad news is that fretting corrosion is not limited to only a few specific parts. As you can see, the list here, almost a lot, high variety of parts is subject of fretting corrosion, or maybe. So yeah, that's why fretting corrosion appears rather frequently. What you can do against fretting corrosion, as already mentioned, it can be a pretty aggressive wear mechanism. And therefore, it's better to avoid it as early as possible. So whenever you start a new development, you should also consider the subject fretting corrosion. There are several design possibilities which you can take, which will reduce for fretting corrosion. Like you see here, you can reduce vibrations, you can have a compact design, you can have elastic intermediate layers. Avoiding rotary bending is quite good. So decrease contact pressure. You see many possibilities which you can take here. Choose hard inert surface coatings like hard chrome, things like that, or carbides. Choose hard steel surfaces. Yeah, that's also good for other wear mechanisms. And last but not least, lubricants play a major role in the avoidance of fretting corrosion, and you can see here. And the lubricant application is important, and also in the area of prefer non-metallic surface coatings, you can use, for example, anti-friction coatings, which also help against fretting corrosion. By the way, this diagram is only the top level. There are several levels below this level, but due to time constraints, we have to stop here the discussion with this. Okay, so lubricants. Yeah, lubricants play a major role in avoiding fretting corrosion. And yeah, any lubrication is better than none, but there are big differences in the result what you are using. Solid friction, mixed friction, fretting corrosion are definitely closely related with solid lubricants. So oils and greases, for example, or products without solid lubricants have a far worse performance against fretting corrosion than solid lubricants. So solid lubricants basically is the state-of-the-art technology to lubricate against fretting corrosion. Also, solid lubricants help to increase the load carrying capacity and have other advantages. So solid lubricants are used in many lubricants like black greases where MOS2 and graphite is used, or white greases where you find hydroxides like carbon hydroxides or phosphates and stuff like that. And yeah, compared to this, our standard non-solid lubricant grease would look like. Yeah, as mentioned, Microglide has for a long time, the first generation was the benchmark in the market for white lubricants for many purposes and also for fretting corrosion, against fretting corrosion. White solid lubricants, yeah, you have heard the name. How do they work? For a long time, it was believed that white solid lubricants only served as a separate agent between the friction partners, which would be quite a good job, like separating the surfaces like little balls between the surfaces so that the surfaces cannot have contact. Graphite, MOS2, they are working in this direction. They produce relatively thick layers of solid matter that can slide easily in the lattice planes and therefore are better suited as dry lubricants. They even work under the absence of oils and greases. You can use them as real dry lubricants as well. A white representative of this category is PTFE. It's a plastic of low surface energy and has quite good lubricity, but it's limited in its load carrying capacity. So MS2, this is the king of load carrying capacity with load carrying capacities over 150 newtons per square millimeter. This is the starting point where MS2 is working, and PTFE is limited to somewhat a maximum of 50 newtons per square millimeter. Okay, so however, the lattice mechanisms has some limitation. If the surface must be protected on a higher level, the keyword is tribochemical reaction layers. Tribochemical reactions layers is of solid lubricants with a metal surface by frictional energy leads to the spontaneous formation of friction and wear reducing reaction layers. The layer thickness is typically between 50 and 200 nanometers. The picture here is showing a wear scar of a test machine. So this one, the dark gray. And here you can see it's different from the metal color, and this is this type of reaction layer. And this kind of reaction layers is helping to avoid wear and is improving friction. Typically, several different solid lubricants are combined to take advantage of synergies. So normally in a grease, you will not find one and only solid lubricant type. You will find a combination of different materials. Important to know that the micro-wide solid lubricants only work in a grease or oil phase. As a pure dry lubricant, without oil, without grease, the friction coefficients are typically too high. So this is a difference to graphite and MS2. MS2 especially is working in a completely dry environment. Graphite needs some humidity, but it does not need oil and grease. Okay, let's go to the next step of the development phase 1 and 2. So somewhere we have to start, and we will see in the next slide some methods used for lubricants development. Before starting a development, you must have a pretty clear idea which product you want to develop. So easily, just let's ask the customer. The voice of customer gives many ideas what is needed. This has to be finally translated into product features. As you can see here, these are some inputs we received from our customers, like white greases, lifetime lubrication, fretting corrosion must be eliminated, pricing, price is always important. We need sustainable and environmental friendly products. So this is the kind of information, there is more, you get from customers when you ask which product they would like to have. When you start the development, from the beginning of the development, you are facing challenges, like which raw materials you're looking for. There are many. Which suppliers you find for these materials. And last but not least, are there legal implications? So there's a lot of research work to do. And a very important point also, and the challenge is to find the cost and time effective test method. The test method is quite crucial for the whole project. For this project, we cooperated with the West Saxon University of Zwickau. This was quite beneficial for both parties. So inputs from both sides, information going back and forth. And so this was quite fruitful and helped to develop the products faster than we could do it alone. The targets are clear. We have to translate all the VOC data into product features. We want significant higher lubrication performance and higher protection against fretting corrosion. And last but not least, we want to have an environmental friendly formulation. So we don't like to see hazard labels on the cans and drums. How to test fretting corrosion? Yeah, we talked about that testing is quite crucial for the development, and therefore a good test method is important. What we have used is the so-called Optimol SRV. In German, it's Schwingreifverschleiß. It's test equipment, it's standardized, and this has been especially designed to test lubricants in fretting corrosion conditions, so the vibration friction wear device. So mostly you're using a ball and you use a plate, both made of chrome 100 chrome 6 steel, and the ball is loaded with a variable force, normal force, and it can move horizontally with a selected frequency and amplitude. Here is, you can see, this is the mechanism the ball is in, and here where the plate is fixed on the test bench. Okay, this slide is showing you all the parameter, so the input parameter with the test we made. So we had a 100 chrome 6 steel ball, 100 chrome 6 plate. We used also other combinations like non-ferrous metals. We used also a combination of cylinder plate. So the cylinder is moving and gives you, instead of a point contact, gives you a line contact. It gives some different outputs. We used the main frequency of 50 Hertz. The oscillation distance, the amplitude was between 80 and 120 microns. By the way, this was a kind of a project itself to find out this type of conditions, to make a selective, to create selective conditions which make it easy to differentiate between different products. We used normal load, temperature, okay, test duration 60 minutes. So normally the test should run for 60 minutes. In some cases it failed and didn't, and we had to stop it earlier. These are the test values, the output. So we get, as a result, we get friction. The fail criteria is when the friction is exceeding 0.3. We get contact resistance, electrical contact resistance. We get some time to build up the resistance layer. We get information about the wear, and we get the time to adhesive failure when the test time is less than 60 minutes. And as we did statistical testing, so we repeated all the tests, so we get all of us also got statistical data. So here we go. The table here is showing some results as an example. It's really just an example. There are thousands of test data. The graph in the circle here is showing a good run, so low friction for the whole time, and a bad run, so early fretting of the combination. So this both happens. And you test the high variety of products here, just 4. You test them with different amplitudes, and you get different frictions, electrical data, and time data. And our development specialist takes this data and translates them into product formulations. As a summary, you can say using small oscillation distance between 80 and 120 microns shows a selective performance difference of lubricants against fretting wear. The lower the possible amplitude, the better the performance against fretting wear. Higher temperature cause more fretting corrosion. This is just what we expect, what you would expect. Measuring the contact resistance and the time until the resistance increasing. Okay, these are some details. Important to know, SRV is not the only test. We have to do many other tests as well. And here we go into the next step. Other tests, so we call it phase 3, prepare for the market, the product validation. What we did, for example, for product validation, we did many tribo testing on various other machines like the SRV. We did some analytical research, which gives us ideas about the characterization of the friction layer, like the XPS analysis. It's an electron microscope, incident light microscope, the TOF SIMS scanning micro. This is time of flight secondary ion mass scanning, thermogravity, and others. So furthermore, we did some testing on special test strips for fretting wear. And finally, we did tests on real machines to get information about the performance of the product at the market. Okay, wear scar analysis. Here you have two wear scars from the SRV, quite typical. And you see the metal around the wear scar has a different color. And yeah, the wear scar has also a color. And with the XPS analysis, you can detect elements on the surface. And this is very helpful. When you look on the clean surface, you get information about the steel. So you get some carbon, you get oxygen, zero phosphorus, no calcium, and lots of iron. Okay, this is what you would expect. With a previous paste, you get the interesting, you see here, you get more oxygen. So something happened on the surface. Some elements have been integrated into the surface. And here with the new one, you see, okay, we have also, the oxygen level is pretty much the same, phosphorus level is higher, calcium level is somewhat lower. But what's important, the layer here almost at the 100% level protects that iron molecules are extracted from the surface. And finally, this is one proof that our theory is right, that we build a tribochemical reaction layer. Again. Okay, so here we come. As mentioned, many other tests followed the SRV tests. The tests you can see here, they are well known in lubrication industry. And so when you have the information 4-ball machine and some okay weld loading number, so the specialist says, oh, this has a good load carrying capacity or a bad load carrying capacity. So all the tests help to characterize the new lubricant and to compare it to other lubricants in terms of performance. So what you get is basically the total performance of a lubricant on test machines. Yeah, tribo tests, many tribo tests, and sometimes you get bad results, but in our case, we got really amazing results. The table is clearly showing with no product generation that this is by far superior to the previous market reference. You have here the values, typical values of a market reference, and you have here Brucker, Reichert, Almen Wieland, and VKA from the new products. And as you can see, here higher is better. So here we are definitely higher. Here is high, lower. Less wear is better than high wear. So here we are lower in wear. I'm in Wieland. Here the problem is that the load carrying of our product is so high that it exceeds the maximum load of the machine. The 4-ball machine, we are definitely higher than the industry reference, and with combined also with lower wear. And screw test, yeah, it's quite similar, but this is we wanted to have because when in screw test, when the friction values are too low, you cannot use the product in combination with screws. So you have to have a certain friction values. And when you see 0.10, 0.08 for steel, so you will get about 0.12 with stainless steel, which is quite beneficial for such combinations. Yeah, as you have heard in other terms, mission completed. When you compare the former industry reference against our 700 series, it's quite clear that gray against green, in all cases, it's much better. The good thing is that the beta is not only some kind of white noise, it's a really step change. Another test. This is quite specific. It's a test, specific test equipment developed in the University of Chemnitz. And this test is a really, really hard test for lubricants to show that they are performing well. So here, so the ring is moved on the surface and will get in contact with the plate, and with a bad lubricant, the surfaces of the ring and the plate will be almost completely destroyed, as you can see. Even when you had MOS2 as a pretty good lubricant, 90% of the surface have been showing adhesive wear. And calcium hydroxide, also a white lubricant, well known, good performance, also shows very high wear on the surface. The new products, the PSV series tested here, they show a significant amount of less wear, so half of calcium hydroxide, or infinity number compared to this when you look 0 against 80 and 90%. As you can see, the surface is almost as new. Another special test, this is a motor generation configuration. So one is the motor, one is the generator, and the motor and generator are coupled with an interlocking coupling. And usually you find lots of fretting corrosion in this coupling. In some cases, you even cannot dismantle this coupling. It's like welded, so very difficult to disassemble when you have lots of fretting corrosion. You can see here quite big areas of the surface show fretting corrosion. Show here with standard EP grease, here with a white paste, but both are failing. And the PSV series, as shown in the previous slides, the surfaces are almost like new. So no rust at all, no wear at all. So the difference is very, very obvious. Okay, going away from test benches, coming to production parts. Here you see part of a spindle. And here on the spindle, there is the seat of a bearing. And as the bearing is creating some micro vibrations, the customer found lots of fretting corrosion here, and a quite dramatic effect. And they had to exchange the whole spindle for thousands of euros only because the bearing seat on the spindle showed fretting corrosion. So we convinced the customer to use PSV 710, a new product. And as you can see here, longer operation time than here. The surface is definitely like new. This is quite an amazing result. And the customer liked this very, very much. This is the spindle. This was a big part, several hundred kilograms. And here you see a very small part. This is an electromotor for a little pump used in medical technology. And here you have the motor, and here you have the pump, and they are coupled via this very simple coupling. But it's working. The only problem the customer had, they had fretting corrosion in a operational time less than 100 hours. And so when having fretting corrosion, the grease was destroyed and it's dropped on the floor of the room where the pump was working in the hospital. And you can imagine that this does not look so nice. So yeah, we changed the former lubricant to our new PSV 765, a grease paste. And you see, even after a very, very long time of 2,500 hours of operation, the surface of the coupling is absolutely perfect, like new. We have talked about grease pastes and lubrication pastes, so the high solid content products. Now we come to the standard grease, so no paste. So we have a real grease with a very low amount of solids inside. And these products are used for ball bearings or for roller bearings. Roller bearings, you might know that the windmill technology, they suffered a lot of false Brinelling, and they had to spend thousands of euros to repair damaged bearings in the windmills. And this was only because of false Brinelling, which is a mechanism related to fretting corrosion. What you can see here is a test rig testing 1 and 2 thrust bearings, ball bearings. The result shows the performance of the grease in terms of lifetime and also of protection against false Brinelling. False Brinelling, as you can see here, is a wear mechanism where you find little pits on the surface of the bearing. And you can imagine that the balls will not roll very smoothly over the pits and furthermore destroy the bearing. Yeah, what you see here is the comparison of the industry reference, as we do, and the new product GSV 791. The gray bars are showing the wear mass, so what was extracted here, of the competitive, and this is the, so we made different tests, and we checked the bearing top left, the bearing bottom left, the bearing top right, and the bearing bottom right. So because we had 2 bearings and each bearing had 2 of these rings. And so what we see, test 1 and test 2, that both tests are in a similar height. And compared to GSV 790, yeah, you have no wear. So you even can measure some increasing weight. That means you measure the reaction layer a little bit. And you definitely see here that GSV 791 is performing by far better than the previous best-in-class product. So much, much less wear. And you can also see this when you look on the grease itself. The reference grease, it was a white grease. This was not black from the beginning. So after the test sequence, the grease is completely black. That means it's cracked. It's dead. And 791, yes, it's gray, but you see the difference. It's not like plastic. It's still a grease. It can be used. It will not last forever, but the condition here is by far better than this one here. And yeah, this reflects also the wear performance. Okay, so just some words. You might wonder what's inside the grease or grease paste. And basically, it's a quite simple process when you know what to do. Quite important, only the best goes into the pot. The quality of the raw materials is important, and using the best process, this is also quite important. The grease or grease paste consists of a thickener, a base and flux oil, some additives, and finally microwide solid lubricants. And you see here, yeah, kind of different thickener types, oil types, additives which you might add, and yeah, the solid lubricants for the tribochemical active protection layer. This slide shows you an overview about the current portfolio of our product range. So this family basically within time will grow a little bit. But as you can see, we can cover many applications as we have different types of products, different oil bases and different soap bases, and all relates to different applications. And all products have in common, they have the novel microwide solid lubricant composition. They build a tribochemical anti-wear layer, very good anti-fretting corrosion protection. And finally, formulations, all formulations are free from hazard labels. They are environmental friendly. Okay, so we have done tests, we have formulated our products, so we should be ready for the market. Here you can see data of our grease pastes and pastes. So what you see here, 710 to 30, these are pastes. 60 to 80, it's a grease paste. As you remember, the level of solids content is lower here in this area. And here you have some test data, and all this test data are helping the specialists to find the right lubricant for your application. These are typical lubricant data and some special data. So you get a good taste what the lubricant, how the lubricant could work. So yeah, here we have pastes and grease pastes, and finally we come to our greases. Greases finally suitable also for ball bearing greases. And as you can see here, the greases have also some test data and some typical product data, like the standard, so the grease standard nomenclature, the appearance, kind of thickener used, service temperature, quite important, drop point, oil separation, all values are typical grease values, and they give you some kind of impression what the grease is, can be used for. Here you can see as a specialty the SRV friction values and the SNR test values. It's different. This you will not find in many other product data sheets, but showing material loss industry standard. Here we have 0, wear depth 0. Yeah, you see better performance in all areas. When you like to compare products, you can use different methods, and one method is to standardize the test values in rankings from 1 to 10, and you have different features you want to rank. So like the anti-fretting corrosion performance, you connect it with a special test value, the speed value, the DN value, for example, or yeah, like a drop point value and product quality. So, and you give all these features some kind of ranking, so you can compare different products optically, for example, with a radar screen. As you can see here, this curve, or the green area, is showing the performance level of the GSV 791. And the yellow dots and the yellow line surrounding the gray area here are showing the performance level of the former industry reference. As you see, this is the translation of the table. And when you look on some wares, you see, fretting corrosion wear, definitely better load carrying capacity, definitely better service temperature. Yeah, it's a little bit better, but this is normal because you design a product for a special operation temperature. The minus temperature, they are on the same level. The DN value, at the moment, the 791 is rated lower, means worse than the competitive product. But this is only because we have not finalized the tests for higher DN values so far. So we are some safety first, so we take the lower value here, but it might be a bit higher. Friction value and adhesion, corrosion protection. You see there, corrosion protection. So corrosion protection is measured with the M-core value, and the best value is 0. And so when you have 0, you can only have 0. So you see it's just the same like the competitive product. Drop point, we are a bit higher because we are using a better quality in terms of soap and oil. So the overall product quality we are ranking as better, and environmental impact definitely is also better. Yeah, on the subject of quality, we just have seen this in the radar graph. Here you have the so-called grindometer. You have here some areas which are milled into the surface with a very exact depth in microns. So it's like here 10 microns, 8 microns. So here you have a quite good, when you put something inside here and go and you can measure the thickness, the particle thickness of a product. And as you can see here, so both products, competitive and ours, have been spreaded into this groove and allow to measure the particle size. So as long as you see scratches like here, you know scratch means there must be a particle inside which is bigger than 20 microns. And as you can see here, it's up to 60 microns. So the product is not really good homogenized. So it has agglomerates, so it has big particle sizes, which have some disadvantages in the final lubrication. When you compare this to our product, you see that it's very smooth, even for higher numbers. So we have small particles, and the product is very, very homogeneous, and this is part of the product and performance quality. Okay, summary and outlook. Yeah, we have succeeded to develop a new generation of micro-wide solid lubricants that combine excellent tribological performance with the best possible environmental friendliness. So no labeling required according to GHS and CLP. This is described in some slides in the beginning. The variation of base oil, thickener, and additive package allows the formulation of tailor-made high-performance lubricants. This is what the customer is interested in, so that he is getting the right lubricant for his application. Currently, We offer following product lines: is the PSV series, lubrication pastes, the FSV series, grease pastes, and the GSV series, it's greases. Just to mention, our technical service is always available for your support. You can reach us under info@microglide.de. You can visit our homepage. You can call us via phone, or you can directly order some samples via Bestellung@microglide.de. Yeah.
Thank you very much.
Thank you for your interest and your attention. As I said, we could only scratch the surfaces of all topics. If you're interested, let us know, so we might set up a further meeting or like that.
Thank you very much, Franz. Very impressive presentation and results. For the audience, thanks for your attention. We will share this presentation with all of you. So we have your email addresses and we'll send it out separately. And if you have any questions according to the presentation, do not hesitate and get in touch. Also, you can make use now of the questioning functionality of this GoToMeeting webinar. You find it on the on your control panel. I have received already some questions, and I'd like to ask the questions directly to our expert, Franz Neuner. Franz, so the first questions are more of general nature. The first question would be, how should I store lubricants like the grease pastes you have presented?
Okay, so yeah, basically storage is from greases and grease pastes is not so critical compared to solvents, but nevertheless you should have a special room, a special stock with more or less controlled temperature. So the temperature should not be too low, so below 5 degrees C, because in cold temperature the grease will become very cold and stiff, so you will have problems to pump it. And also it should not be too hot, so because when you have temperatures above 30 degrees C, the product is aging a little bit faster than it should, and also the oil separation will be a little bit higher than usual.
Thank you. And then another question is about, can I mix different greases and oils?
Basically, yes. So this is a question which is quite common, for example, with engine oils. And the rule of thumb is when you have a grease or a product, it can be an oil, a grease, a paste, which has the same base like a lithium or a calcium soap, and has the same type of oil, like both have a mineral oil, they probably can be mixed. But some oils and some soaps are not interchangeable. So therefore, the best is, if you are not 100% sure, just let us know, send us an email, and we will check the situation.
Then we have received a question about phosphated fasteners and whether we have a lubricant for phosphated fasteners in the transmission with a grease. So I think we should discuss this separately. We do have in our portfolio of dry film lubricants products for phosphated fasteners. And depending on the dimensions, we may also talk about a grease paste. Franz, do you have to add something to this?
Okay, yeah, just one sentence. When you have a phosphated screw and you use a grease paste, just take care about the coefficient of friction, because phosphating plus grease, it's a lubrication, the level is even higher. So the coefficient of friction may be going down and reach a limit which you don't like. And therefore, just check up front, but basically no problem. You can use any grease or paste with phosphated surfaces, but take care about the coefficient of friction.
Yeah. And then there is a question, is there any new lubricant for compressor, especially when polymer-based composite piston rings are used?
This it comes with which part you're talking about. So we do not have products like the oils used for compressors, the compressor oils. So we don't have compressor oils in our portfolio. Nevertheless, for example, when you assemble a compressor, you need to press bearings on the wheels, for example, and there you can use white greases, white pastes very beneficially. And also, you might think, for example, for oil-free compressors, you can use anti-friction coatings as a emergency running layer on top of the compression surface, compressor screw surface. So this is a difficult subject. So in terms of oil, no. In terms of other lubrication, we have to talk.
Thank you, Franz. Another question is about how to choose the best product, grease paste or paste, difference in percentage of solid content, etc. So like I said earlier, I think once we've shared this presentation with all the data, and also you can check out our website, microglide.de. In the section knowledge and downloads, you can find a lot of literature about this fretting corrosion phenomenon, Microglide GSV 7 series, the new generation grease pastes. And finally, of course, we are always at your disposal via email or via telephone to consult you to find the best product for your application.
Yeah, and at the moment I'm also working on another seminar or webinar presentation about exactly this subject, how to, from the idea to the lubricant in practice. So how to find the right lubricant. As it is a question which is quite complex when you go in depth, and therefore it needs another presentation.
Yeah, so if you are interested to order samples, if you want to test the products, if you experience any type of fretting corrosion, tribo-corrosion, false Brinelling, what you have seen here, according to the pictures on your parts, on your application, feel free to get in touch and we consult with you, and we are happy to provide you with product samples so you can convince yourself about the performance of our products. That was it regarding questions. Again, we are available if there are more questions going forward. Thank you very much, everyone, for attending and your interaction. We hope that we could give you some insight into this phenomenon, in this industry problem, in this wear problem, and we could demonstrate our competency in this area. Thank you very much. And with this, I would close the meeting. We are 2 minutes before 11. We don't want to waste your precious time. Again, thank you very much for attending and looking forward to individual discussions with you. Thank you. And thanks, Franz.
Bye.
Bye.